So for section 3-3, we're talking about proving lines parallel here. And look for a second at the screen, look at your notes, and look right here. What is the key word that you see right here? Did you see the word converse? Think back a ways. You just took a test on this. Think back to what converse means. Converse means that you take the sentence and you reverse it. You put it backwards. So yesterday and the day before, we talked about if two lines are parallel, then certain rules apply. If two lines are parallel, then the corresponding angles are congruent. Well, this is the converse, so it goes backwards. If lines are cut by transversal so that corresponding angles are congruent, then the lines are parallel. It's just taking the same rule that we had before and writing it backwards. Think about this one. If two coplanar lines are cut by transversal so that the alternate interior angles are supposed to be congruent, then the lines are parallel. And likewise, alternate exterior angles are supposed to be congruent. When two lines are cut so that the transversal makes alternate exterior angles congruent, then the lines are parallel. But this one's special because it's the same side. And if two coplanar lines are cut by a transversal so that the same side interior angles are supplementary, then you can say the lines are parallel. So don't let this confuse you too much. The regular theorem goes one direction. The converse just says it backwards. What's the difference between the theorem or the converse? Look at this theorem. If lines are parallel, then corresponding angles are congruent. Think in your mind, what would the converse say? It would go backwards. If corresponding angles are congruent, then the lines are parallel. You don't have to write this down. This is just something to look at and think about. So let's practice this a little bit. The regular theorem says, it starts out by saying if lines are parallel, then something happens. The converse ends with that, then lines are parallel. So that's the trick. So look at this case. If we know that M is parallel to N, if we're told that M is parallel to N, then we're allowed to say that angle 3 is congruent to angle 4. We started off by knowing that lines are parallel. That is a regular theorem. That's not the converse. And which theorem is it? These are corresponding angles, so it'd be the corresponding angles theorem. Look at another one. In this case, if angle 7 is congruent to angle 8, then the lines are parallel. A is parallel to B. In this case, it went backwards because the parallel lines is the conclusion. It's at the end of the statement. So that makes it a converse. We're showing that lines are parallel, proving that lines are parallel. That makes it a converse. Which converse is it? Well, since these are alternate exterior angles, it's the alternate exterior angles converse. Next one. If angle 1 is congruent to angle 2, then S is parallel to T. It's about the order. Look, where are the lines parallel? Is it at the beginning or at the end? It's at the end, which is backwards, so we use a converse. And in this case, 1 and 2 are alternate interior angles, so it's the alternate interior angles converse. And the last one, look at this one. If J is parallel to K, then think about this. Are you going to say these are congruent or supplementary? That's right, they're supplementary. Then 6 and 8 are supplementary. Was this a regular theorem or was this a converse? Look where the parallel lines are. The parallel lines are at the beginning of the statement. That makes it a regular theorem, not a converse. And 6 and 8 are same side interior angles, so it's the same side interior angles theorem. So look at number 7. We are being told that angle 1 here is congruent to angle 8. First thing to notice is the transversal that's cutting through there. The transversal is going through right there, line E. So the next question they say is determine which lines, if any, are parallel from that. So which two lines would have to be parallel? It's the lines that go through each of the angles. So I'm going to put the markings there. This line would have to be parallel to this line, because that's where the angle 1 is, and that's where angle 8 is. So C would be parallel to D. C parallel to D. And then the second part of the question is state the postulate or theorem that justifies your answer. Well, we're saying that lines are parallel, so we're going to use a converse. Okay, we don't already know the lines are parallel. We're saying the lines are parallel. We're ending with that. And then when you look at the picture, angle 1 and angle 8 are alternate exterior angles, converse of the alternate exterior angles theorem. I know this is tricky at first, so just write that down for now and concentrate on this next one with me. Number 8, it says that 4 is congruent to 9. Angle 4 here is congruent to angle 9. First of all, the transversal that has to go through both of them, that cuts right through both of them, is line C. So that's not one of the parallel ones, that's the transversal. The lines that are parallel are the lines that go through each individual angle. Here's the 4. The line that's going through it is line E. And here's the 9. The line that's going through it is line F. So those are your parallel lines. Line E is parallel to line F. If you look closely at the relationship between angle 4 and 9, they are alternate interior angles. So am I going to use the alternate interior angles theorem or the converse? Well, look, I know that the angles are congruent. I'm saying therefore lines are parallel. That's going backwards. That's the converse. The converse of which one? In this case, it's the alternate interior angles. Converse of the alternate interior angles theorem. Look at number 9 while I'm erasing. Look at the relationship between the 7 and the 13. 7 is here, and 13 is here. Okay, first of all, the transversal that goes through them is line D. But which lines are parallel from this relationship? Well, the line that goes strictly through the 7 is line E right here. And what's the line that goes through the 13? That's this one, line F. So these are your two parallel lines right here, E and F. Look at the relationship. 7 and 13 are both inside, but they're on the same side of the transversal. Okay, well, the lines that are parallel would be lines E and F. The transversal is D. But the relationship is that these are same side interior angles. Now, is it the theorem or is it the converse? It's all about where the parallel lines are. Here in number 9, I said, if this is true, then the lines are parallel. That makes it the converse. Converse of the same side interior angles theorem. And try number 10 on your own right now. Nine and 13. First of all, get in your mind what 9 and 13. First of all, get in your mind what the transversal is. What's the line that cuts through both of them at the same time? That's line F. F is the transversal. Now, what are the two parallel lines? Line C goes through angle 9 only, and line D goes through angle 13 only. These are the two parallel lines. Look at the order of the statement here. If two angles are congruent, then the lines are parallel. That's the converse. It's going backwards. It's ending with parallel lines. So what is it the converse of? Look at the picture. 9 and 13 are corresponding angles. So it's the converse of corresponding angles theorem. Okay, we're going to do one last proof, but this one you don't have to come up with the answers yourself. The 4 choices are right here. Obviously, given is the easiest one to do. We were given here that angle 1 and angle 3 are supplementary. So here I see 1 and 3 are supplementary, so I'm going to write given right there. And I'm going to say that one's been used. Okay, number 2 asks me to use the linear pair theorem. Look at your picture. Where do you see linear pairs? I see a linear pair right here. 2 and 3 next to each other form a straight line. So I'm going to look over at my choices, and the linear pair theorem says that when you have a linear pair, then they are supplementary. So 2 and 3 are a linear pair, therefore 2 and 3 are supplementary. That goes right here. Next, says angle 1 is congruent to angle 2. Look at your picture. Be careful here. I'm not allowed to say 1 is congruent to 2 because of the corresponding angles theorem, because I don't know yet that m is parallel to n. That's what I'm trying to prove at the end. So I had to get there another way. Look at this. Angle 1 and 3 are supplementary. Angle 2 and angle 3 are supplementary. We talked about this a while ago. When two angles are supplementary to the exact same angle, then these two angles must be equal to each other as well. That's called the congruent supplements theorem. So write that down right here and eliminate that from our choices. And lastly, of course, there's only one left, but think about it. If angle 1 is congruent to angle 2 right here, angle 1 is congruent to angle 2, then you're allowed to say that that makes the lines parallel. M is parallel to N. Why? Because the corresponding angles were congruent. And that is the converse. If angles are congruent, then the lines are parallel. That's the converse of the corresponding angles postulate. So cross that off the list and we are done.